Hi friends, so all of you again, welcome on this YouTube channel. And in the first video, we have covered for the manual testing, right? Where we have seen some concept about like in part one, we have talked about what is testing. But before jumping on that, I welcome to all of you again. My name is Nitesh, and thank you so much for watching this video. This video is in the same series of a part 2. If you have not watched part 1, please go and watch part 1. Right, I am giving the link in this description. So in part 1, we have covered what is a testing, why it is important, what is the objective of a testing. People usually confuse what is a definition of a testing, what is a benefit, why we do the testing, what are the myths about testing. So we have discussed around 10 myths about testing, right? In part 2, as I promised, we are going to cover testing principles. So there are 7 principles as per ISTQB. ISTQB is a renowned certification to a testing. The first principle is testing shows presence of a defect. We have one myth that testing, if any software has been tested completely, right, it should be a defect free. Absolutely it is not, because even though defect can be exist, but yes, we need to take care that any business requirement should not miss, right? So let's continue for the first principle. As I said, testing shows presence of a defect, not their absence. What is the meaning of that? If your customer, or if it is expected that you have done your testing and there is still some defects are there, right, or your software is not having any defect, it is absolutely a myth. It could be have some defect, but yes, you should take care that all the requirement which has been agreed, that should be followed by your software, right? That is the first principle. Second principle is exhaustive testing is not possible, right? So to showcase you exhaustive testing is not possible, let me draw something for you, right? And let's see how it is, how it can be explained. Okay, let me explain how this second principle is working here. For example, let's suppose you have to test one printer, right? And printer have three types of a printer from HP, Epson, and Canon. So you will make three test case. If I'm increasing one attribute, right, which you need to include more, correct? So what will happen? Like it's a connectivity, Bluetooth, Wi-Fi, LAN. So you have to here create 9 test cases, 3 into 3 test cases for each one. So it will be 9. If I include one more attribute like weight, it's a 5 kg and 3 kg, then you have to include two more test cases for each category. So total 9 into 18, 9 into 2, that will be 18 test case. If I include one more attribute here, like pages, it is printing A3, A4, B4, so it will be 18 into 3, that is a 54 test cases, correct? If I include one more attribute, right? In the similar way, if you can see here, even if there are only 8 attributes, right, under some categories, here we have 1944, approximately 2000 test case you have to run. Now we do not have such time, right? So what we do in that case, we write only the important test cases here, right, and do a combination of that. For example, few test case you will pick that printer name, which connectivity, then what page size, what is the weight, right? So we will bring it here. Now the second principle, exhaustive testing is impossible, means you cannot do exhaustive testing, right? It's impossible. The third principle is saying early testing is always good, because as early we find the defect, right, it is easy to fix those defects and it is less costly. Now how this is, let's try to understand. Let's suppose why I am saying that early defect is easy to find out, right? Let's suppose, now we know this is our V model, right? The first one is your requirement, then after that there is a design, then after that there is a development, then after that there is a unit testing, then after that there is a unit integration testing, right? Then there is a software testing, correct? And then there is a software integration testing, and then after that there is a your acceptance testing. So let's suppose if any defect found at this stage, right, during your requirement, at that time it is very easy to fix because your BA will take a consideration from your customer or client, and requirement can be changed. In case, let's suppose any defect found during your acceptance testing. Now what will happen? BA needs to analyze that is it really any requirement was missed, or we need to, the defect which has been raised is not exactly right defect, right? So again, this defect will come back here to your developer, do some analysis, then architect, then BA. So it will take time to fix, right? And multiple people are going to engage. Plus, apart from that, since we have already built in other functionalities, might be the defect fix can impact the other functionality as well, or other area of the software. So that's why defect whichever has been found early in stages, it is easy to fix, it is less costly, and it is less involving to the people. So second principle is talking about now that. The third principle is defect clustering. I tell you one thing, in your city, wherever you are living, right, you have found that few area is famous for something. Like you can go and buy the cloth in few area you will find that you can find hardwares. Few areas there like there is a software, or you can find in your city there is. The question is why in particular area those shops are found, because if you go at that place, right, you will find other options as well. Here defect clustering meaning if you find the defect at one place, right, there is a very high chance that that defect can impact the other functionality as well. So to understand, let me explain you with one example. So let's try to understand this principle from one of the example. Let's use a calculator here, and for calculator we know the basic functionalities are like your addition, right, the symbol is plus, subtraction, the symbol is hyphen, multiplication, the symbol is star, and division, the symbol is slash, right? Now if we know that if we are using 16 divided by 4, we will get the answer 4, correct? But if I am using 16 because the wrong implementation, let's suppose, has been done by your developer, instead of division sign, the developer has used mod functionality. So 16 mod 4, you will get the 0 answer because there is no reminder, correct? Now the defect will come whenever you will use this division functionality. Now defect clustering says that it is not only that this particular functionality is going to impact, even though if I am using any expression where this division is going to use, let's suppose 16 plus 60 minus 7 into 8 divided by 6, I will get the incorrect result here as well, because division was not implemented correctly. Instead of division, the developer has used the mod functionality. This is nothing but principle is which is dictated here, that is the defect clustering. So if the defect has been found in one functionality, it may be impact the other functionality as well. Got it? Fine. Another principle is talking about the pesticide paradox. If I ask one question from you, right, that long time back you were using the mosquito repellent, correct? So mosquito repellent that nowadays we are using is having the similar capacity or it has a different capacity. So you will say the resistivity power for mosquito repellent which is used nowadays is more stronger in comparison to the previous one. Why this is so? Because mosquitoes are now becoming more strong. So the same thing this principle is talking about, pesticide paradox. If we are running the same test case again and again and again, this there is a very rare chances that you can find a new defect by using the same test cases. That is the fifth principle. So we have to update our test cases, we have to update our regression suite every time. Now the sixth principle is talking about testing is a context dependent. Means if I am doing testing for a banking domain application, the approach is different. Way of doing testing could be a same, but approach is different. If I am doing a testing for any e-commerce website, for payment gateway, for insurance domain, for aviation, for education based industry, the way or testing approach will different, right, for every domain. So the sixth principle is testing is a context dependent. The seventh principle is absence of error fallacy. So let's try to understand what is the absence of error fallacy. Absence of error fallacy, as you are seeing on my screen, that your customer has given some requirement. Customer is expecting that one animal which should be having a trunk, it should be having a four legs, it should carry load and passenger both, right? And it should be black in color and it should be herbivorous. Whereas I understood the requirement incorrectly and I am delivering another software, I am delivering another animal, and in second image our solution you can look that it is having one trunk, it is having four legs, can carry load and passenger both, right? Black in color, herbivorous, and additional thing which we are giving, it is giving milk. Now from solution perspective we are right, because what customer was expecting, but and what we have delivered, even we are delivering some additional values. Ideally, if you will compare, so do you think the customer will happy? Absolutely no, because customer was expecting something different and what we have delivered. So the air seventh principle which is talking here, absence of error fallacy, if we have understood something wrongly, right? So the wrong test case will be created and the wrong execution will be done. So whenever requirement has been given to you, just make sure that you understood the requirement very correctly. Correct? It's a very important. So these are the seven principles for which we were talking about. These are the fundamental seven principles that has been mentioned in your ISTQB as well, and these are very important. As a manual tester, you should know these software testing principles. Correct. Now if I move to the next one, so here it is a testing process. Now what is a process? Process is nothing but it is a set of some activities. In the similar way, testing has some activities which is your complete testing process. But before jumping on understanding the testing process, let's understand which are the factors that can impact your testing process. So those factors like your which SDLC you are following, whether you are following sequential, you are following iterative and incremental. So these steps can be altered as well or modified as well. What test levels, what test types you are considering, means test levels. If I talk about, although I will cover in upcoming slides. So what test levels, like there is a component integration, system integration, acceptance. Sometimes you only do the testing for a system integration. Component integration is done by your developer. Acceptance testing is done by your business people. So what test levels you are following? What test types, whether functional, non-functional, what test types you are following? Right? Then what is your product and project risk? How big your project? What is the use of the product? What is the use of that project? Right? How complex it is? Right? Which kind of a user you are targeting? That also influences your testing process. What business domain? If I'm talking about any BFSI, any banking related, so you have to make sure that the security testing is must be followed. The performance should be very good. The calculation should be very fine, right? Other constraint, like there is what is your budget, what is the time complexity, what is the time you have given, right? If you have a good budget, then you can do a testing in much detail, but you have a very less time, very less number of resources, the budget is very strict, so you cannot do the testing in a much detail, right? What is a contractual regularity requirement? What is your organization policy, whether it is CMI level 5 or 3, which organization it is, what kind of an internal is external standard we are going to follow. So these factors always impact your testing process. Now if I talk about what activities that makes a testing process, so the first one is your planning. When we plan for the testing, what is in my scope, what is out of scope, what is my test strategy, what we are going to test, why we are going to test. Monitoring and control, it is ongoing activity, means if your project is going in a red status, right, whatever you have expected you are not completing in a given time frame, so you have to monitor, and this is the ongoing activity, and you have to put some control, what action you can take to make your project come in green status, right? Then there is a test analysis, means understanding the requirement, Then after that, once you understand the requirement, do the test designing, which is you're writing the test case. Then once you write the test case, you bring them into multiple test suites accordingly how you have to execute. That is nothing but known as your test implementation. Then after that, once test suites has been decided, your test data is there, right? You do start your testing. That is your execution. And once execution, you raise the defect has been fixed, then you retest the defect and you give a sign off on that, right? Then once execution has been completed, then you do your whole sign off, that is your completion. During your completion, you send a completion report. If there is something you have to procure for future, you just save it and give your agreement that testing has been completed. Now the product or feature can move from this phase to another phase. So these are the 7 testing actions, which activities which makes a complete testing process, right? In the next, we are talking about what is the difference between QA and QC. Now, most of the time you heard we are a QA people, but ideally we are not only the QA people, because QA means quality assurance, right? And there is a QC, but which is a quality control, right? We are a quality management guys, right? We are not only QA people. So why I am saying this, and what is the difference between QA, QC, and QM, we will study and understand in the upcoming video, because I do not want to put any video very long. So it will become interesting for you to understand the concept and grab the things. So thank you so much friends for watching this video, and if you have not liked the video, not subscribed the video, please subscribe it, share with your friends. And in the next video we will talk about the difference between QA, QC and quality management. Rest we will discuss about other things like what is the difference between error, bug, fault and failure. We will discuss about the difference in all of them. We will discuss about debugging. We will discuss about the different SDLC like sequential and iterative incremental, which is your agile. We will discuss about what is the advantage, disadvantage. We will discuss about what is the difference between iterative and incremental. We will discuss about the different test levels. We will talk about different test types. We will talk about functional versus non-functional. We will discuss about difference between manual and automation, where you can apply manual, where you can apply automation testing. Then we will talk about how we can perform the manual testing. Then we will talk about what is a review testing or a static testing, why it is important, how you can play a good role in that. Then we will talk about the test techniques, how we can write our test case. Then we will talk about the test management, the difference between test plan, test strategy. We will talk about the defect life cycle. We will talk about the difference between retesting, regression, smoke and sanity. And then we will talk about what are the testing artifacts. So please subscribe the channel if you have not liked, and I will see you in the next video, that is a part 3 of a manual testing. Take care. Bye bye. Thank you.